Okay, the purpose of this demonstration is to try and motivate the study of systems and motions of masses. So what I'd like to do is build a model of a device that might parallel park or park a vehicle. I'm going to try to keep it as simple as possible to give you the idea of what we're going to do. So I'm going to create a model. I'm going to call it park. I'm going to select my units, gravity units. I want things that I'm familiar with, kilograms, etc. And so we'll create this model. And the first thing I'm going to do is to create a couple of masses, which will be, they'll act like cars. So I'm going to select a box. I'm going to put it over towards the right hand side. That looks good. Then I'll create another one, same size, and I'll put it over to the left. Next thing I'm going to do is name them. So part 3 is the green one, and I'm going to right click and I'm going to rename this. This is going to be my moving part. And then I'm going to select this one, right click on him. I'm going to rename. I'm going to call it stopped. That's going to be my stopped car. Next thing I'm going to do is constrain them so they can only move in one direction. Just to keep things simple again. So I'm going to create a sliding or prismatic joint. Here I'm going to, it tells me at the bottom, select the first body. So I'm going to put a joint on the moving body, between the moving body and the ground. I'm going to locate it at the center of mass, and I'm going to put it in the center of mass Z direction. I'm going to do the same thing over here for the parked mass. So let me just slide him over a little bit. So I'm going to select another connector. I'm going to select the body, the ground, center of mass, and I'm going to align that in the X direction. Okay, so let's see. Slide it back so I can see it. Now the next thing I'm going to do is assume that I have a force on the moving object that it basically is the engine. So I'm saying that I have control over the engine, and I can have the engine apply a force to the mass. And this will be either a forward force or a negative force, whichever I need. So the backward force would, you can imagine comes from the brakes. Forward force comes from the engine. So anyway, I'm going to create a force, single component force. I'm going to fix it in space. It's just going to be either forward to the right or to the left is all. I'm going to react against the ground. So you think of that as, the tires are going to be pushing on the ground. And I'm going to create a magnitude. For right now, I'm just going to give it a 1 Newton force. So now that I have that, tells me to select the body that the force is going to act on. So I'm going to say it's on the moving body. Point of application is going to be the center of mass of that body. And now it's asking me to find the positive direction of the force. And so I want the center of mass Z direction. So there's my force. Okay. So if I wanted to simulate, let me save it. And so let me simulate it and just see what happens. If you apply a constant force to this, it should just accelerate to the right. And I like to use step size. Yeah, that's probably good enough. And so we'll simulate it. And you can see it moves forward. If we put a duration, we can just do 5 seconds, 5 seconds, boom. All right. So next thing I'm going to do is make it a little bit more realistic. I'm going to create a contact force between the two automobiles. So I go to Forces, select Contact, it pops up this window, double click here, and it allows me to select in here. I'm going to put a contact between the moving box and the stopped box. It's going to be an impact. I don't need friction because it's just going to be a normal force. So I'm going to say OK. So now I have a contact force. So if I simulate this again, bang. So we'll expand this. Whoops. Let's see. Shrink it down a little bit. All right, there we go. And slide it over. All right. Rewind it. And simulate it again. So it just pushes the red car out of the way. That's not too good. What I would like to do is control the moving car so it doesn't hit it. And at this point, I would say, you know, what would be neat, I think, I'm going to rewind it. What would be neat is to have, if I had a spring between the two vehicles, I'm going to shade it in, maybe it looks a little better that way. If I had a spring between the two vehicles, it would be it would behave the way I might want it to, because then the spring force could keep the two vehicles separated. So I'm going to do that. Before I do, I'm going to try to measure the distances between the two so that I can figure out what I want to put in there. So I am going to take a, let's see, I think, oh, here we go, a measure. Okay, so I'm going to create a point-to-point measure, and I want to measure the displacement, the magnitude. Let's see, yeah, we'll take the magnitude. Let's see, click the advanced. I'm going to name this distance, and this is going to be the distance between the cars. So I'm going to measure to a point. So I'm going to click on that, and I want the stopped vehicles center of mass. So I'm going to measure to the center of mass of the stopped vehicle, and I'm going to measure from the moving center of mass. I want the translational displacement. I want it in the x direction. I want the coordinates measured in, I'm going to choose the stopped box. This doesn't so much matter as long as things are not rotating. As soon as they begin to rotate, then you have an issue with it. So I'm going to measure my distances relative to the stopped vehicle. Okay, and so I'm going to say apply, and immediately what happens is a strip chart pops up, and this is the distance that was from the previous simulation that I did. And you can see that, you know, at some point the two centers of mass hit and they don't get any closer. Okay, I'm going to also create a velocity. So I'm going to come up here to the same dialog box I had before, and I'm going to create velocity or speed. So we'll do speed. I'm going to go between the same 2 points. This time I'm going to measure the translational velocity in the x direction, in the coordinates, the time derivatives. Since I'm taking a derivative of this, you have to specify what coordinate system. I want to measure or take my derivatives relative to the ground. So I'm just going to select this guy, and I'm going to say OK. And here is the velocities between the two. right? And so you can see where it hit. Okay, so now that I have that, what I want to do is I want to create a spring between the red and the green. And of course, what you could do is you could come in here and you have a spring, but that's not realistic. You can't really put a spring, can't jump out of your car and go put a spring in something. So what I'm going to do is I'm going to create this force. I double click it so it'll allow me to edit it. And I'm going to, for this function, I'm going to go to the function generator. Pops up this this thing. And what I'm going to do is I'm going to modify this and I'm going to put in a spring force. And if I had a spring force between these two cars, it would have a spring constant, which I'm going to take to be 1. So it'll be spring constant. The magnitude of the spring force will be spring constant times, and I'm going to put the deformation of the spring. The spring is going to be the distance between the cars. So I'm going to go to measures. I'm going to double click here, and it opens up and provides me the measures that I have just created. And so I want distance, right? So I'm going to specify the distance of this thing, goes in here, right? And I'm going to insert it, so it goes in right here. And I'm going to subtract the free length of the spring. So the free length, I'll say, is maybe 1. I'm going to try to experiment with these numbers in a little bit. So that right there would be a spring force, and the spring force is going to be the distance minus 1 times a spring constant of 1. So now the next thing I'm going to do is verify that I haven't made a mistake in the formula. So I click verify, and it says yep, it's right. So I'm going to say OK, and I'm going to say OK, which will close this window. Now I believe that let's see. Oh no, okay. Let me go back there. No, there it is. It's in here. But I believe I also have to click apply here. I'm not real sure, but I'm going to click apply. Okay, so let me just drag this guy out of the way. And here are my distances and my speeds. I'll shrink it down a little bit. And we will pull our simulation control back up, rewind it, and we'll run it. We'll make a duration a little bit bigger, 50 seconds. Okay, so you can see that what happens is the green box acts like there is a spring between the two, right? If you had made a mistake, for example, on this guy and thought that the spring force should have been negative, then what you'll find is that this is going to be unstable. So watch. So initially the spring force is negative, and so it pushes it away. Right, and the further it pushes it, the further it goes. The further it goes, the greater the force, and eventually the thing is moving like crazy. So you can see by the very large speed. So when you do this, you need to make sure you have the correct plus minus sign. Okay. Now, obviously, if you just have a spring between this thing, it's going to wiggle back and forth forever. So what I'd like to do is I'd like it to stop moving. So I'm going to go back in here to the the spring, or to the force. Now I'm going to add a damper. So I'm going to say, okay, I'm going to put in a damping. So we'll have a value of C. This will be the damping coefficient times, in this case, it should be the velocity. And so I'm going to, selected the measures. I double click here, and this time I'm going to put in speed, insert it. If you wanted it to, if this was a cruise control, for example, you would say, I'm going to subtract off a desired speed, so that when you hit the desired speed, you'll get a 0 here, and you get no damping. But for example, if you wanted to go 10, you'd put a value in here. I want it to stop, so I'm going to say minus 0. And so now I have a spring force, right here, and I have a damping force right there. And I'm going to verify it. It says it's okay, so I'm going to say okay. I'm going to say apply, which I'm not sure if I have to or not, but I'm going to drag this out of the way, rewind the simulation, and simulate it. Okay, so I think you can see that what's happening is the speed is dropping off, and so is the amplitude. But that's probably not that good, right? So what I'd like is I would like to get the green box a little closer to the red, and I don't want it to oscillate so much. So what I'm going to do is I'm going to modify the force a little bit. So I'm going to say, okay, if I want to get there, if I want it to damp out, I want a larger damping coefficient. So I'm going to put a larger damper in here. And I want it to get closer to the red guy. So instead of being a distance of 1, I'm going to put it in as, let's try 0.2. I'm going to apply, rewind, and let it rip. Ooh, a little too much. Okay, so it hit. So let's see, I'm going to try to increase the damping so it doesn't overshoot. And let's try a 0.3 distance. Rewind, simulate. Okay, so we'll just kind of keep going. So you can see it comes in and stops. Okay, so the idea of why you're studying systems is, suppose you wanted this thing to go much faster. You wanted to park quickly. You want to specify the distance. You want to make sure that it doesn't oscillate. So what you would do is you would try to calculate what the damping would need to be, what the parking distance would be, what kind of spring constant you want to use so that you can get the response that you're looking for. And those are the things that I'm teaching in this class, is how do you specify the kind of response that you want so you get the car behaving properly. Just a final example, and then we'll quit. I'm going to increase the spring force. So basically I'm saying that it's got a stiffer spring, and so can you imagine what's going to happen when I apply this? Let's find out. So I'm going to rewind it and let it rip. Boom. So what's happening is now, because the spring force is so large, it picks up and goes quickly, but it overshoots. It doesn't have it has under damped. It doesn't have enough damping force by increasing the spring force. So that's it. There are a number of applications like this. This is just one example, one simple example. Hopefully motivate the study of system dynamics.